Okay, today I'm going to go over slope finding the slope from a graph. So the first thing I want to review with you real quick is what is slope? Slope shows us how steep a line is, and we can find the steepness or how it's tilted by finding the rate of change between the y variables and the x values. So I like to do this little triangle. Change in y divided by the change in x represents our slope. Or another way we could write it is rise over run. Or the formula, which is y2 minus y1 divided by x2 minus x1. The difference in the y's is your change in y, and then the change in the x is represented by the difference in the x's, subtracting the x values. Okay, so let's take a look at this first graph. There's not points marked on the graph, but we can tell where it crosses the corners. I'm going to kind of mark them right here. So on a graph, I like to, sometimes you can mark out your little triangles. But one thing you have to be careful is you have to look at the scale of the axis. So if you look at this y-axis, I know a lot of people want to think, oh, I'm going up 1 and over 1, 2, 3, 4, so the slope is 1/4. But this y scale is not counting by ones, it's counting by what? Tens, right. So when I go from -10 to 0, I'm really increasing 10. This is going up 10, and then my x-axis is counting by ones, so I can say 1, 2, 3, 4. So I'm going rising 10 and running 4, and this simplifies to 5/2. So that would be the slope of that graph. Okay, let's take a look at the next one. Here we have points marked on our graph. If I make my little similar triangles, or my little congruent triangles, this change right here, I went from 18 down to 14. So I'm not going down 2. I'm actually, since the y-axis is counting by 2's, I'm going down, I don't know what that, down 4. This is a negative slope because it's going downhill. It's going downhill, so I'm going down 2, 4, and then the x-axis is counting by 1, so this is 1, 2. So down 4/2, which give me a slope of -2. I'm going to go on to this one right here. So this next graph shows the weight of a jar with marbles, and the weight depends on the number of marbles. So again, this one doesn't have points marked, so I'm going to find on the graph, on the line, where it crosses a corner. So one would be right here. So I'm going to mark this one. And then the next one where I see where it crosses is right here. So I'm going to mark that right here. And then I'm going to draw my little triangle. So I want to find my change in my y, this change divided by this change. So you want to look at your change here. So we started at 40 and we went up to 100 because this is counting by 20s, right? 20, 40, 60, 80, 100. So we're not at 100. We didn't go up 100. We went up from 40 to 100. So you can think of this as the change in the y. So that's a change of 60 from 40 to 100 is up 20, 40, 60. And then the change in the x, we went from 10 to 30. So that's a change. A 30 minus 10 would be a change of 20. I'm kind of doing the slope formula here. 60 divided by 20 is 3, so this is going to have a slope of 3. Or you could say 3/1, which equals 3. So you're going up 60, 20, 40, 60, because we're counting by 20s on the y, and then we're counting by 10s on the x's, so 10, 20 is your change in your x. So 60/20 equals 3. The last one This is proportional. It starts at 0, 0. So it looks like if you want to initially think, oh, I'm going up 1 over 1. But again, the scale is, well, from here, 0 to here is 250. So what would halfway be? What's half of 250? 125. So I'm rising up 125 and then running over 1. So this would have a slope of 125. So the thing you want to be careful about is looking at your scale and making sure that you don't just count the boxes as one unit if the scale is not counting by ones. And it's the vertical change in the y on top over the change in the x on the bottom. And that is how you find slope from a graph.